All right, everyone, welcome back. In the last video, we got introduced to methods. Now, this unit isn't exactly about methods. It's all about strings, but we're going to be using CodingBat as a tool in order to practice strings, a very, very valuable tool. In order to do that, we need to have a little understanding about methods. Realities are I'm teaching you more than you need to know, but it's going to help. So there's a lot of information in the last video, but we kind of ended here where we take a method signature. This particular method is called max. It's defined in a class called methods. It takes in two integers. It returns a single integer, and the underline means it's static. Now, a lot of that stuff I do kind of expect you to know. The static part, don't worry about what static is. Just know that for right now, the methods that we're writing have to be static. So here is the max method that we ended up writing, right? IntelliJ is adding in some helper text here, this X and the Y. The actual method call looks like this, right? We're saying, what is the maximum between 4 and 8? It is getting called right here. We're using a system.out.println line in order to print the result. You could, in theory, create a variable and save in the value that's returned. Right? I like showing this because it more clearly shows that this is returning or producing or evaluating to an integer. The integer that this outputs is being saved into a variable. Okay, here I'm just printing it directly. Those are kind of your options. So this is the method call. I told you in the last video, there's kind of two parts to a method. There's one part where we say, all right, let's execute a segment of code. And then there's the method definition, which is the actual segment of code that gets executed. Notice that this method is written in the body of the class and not the main method, right? The main method is a method itself. So this tells us that methods belong in the class body. You can't actually define a method inside of a method. So whenever we do this, we're going to tell this section of code to execute. We're sending in the value 4. That'll be treated as X inside of our method. We're sending in the value 8. That'll be treated as Y inside of our method. We're going to ask, is 4 greater than 8? That is false. And so we skip over this and instead hit this return statement, which is the point at which we actually output. So in this case, it would return 8, and that's what we should see. I'm actually going to run this super fast, and we'll see that result. Okay. And to kind of prove the point, I can flip these. Let's make X actually greater than Y. Okay, in this case, we're calling max, passing in a 7, right? The 7 will be treated as X for the rest of the method. The 5 will be treated as Y for the rest of the method. We're going to ask, is 7 greater than 5? It is. So we enter the body of the if statement and we return X, which is 7 in this case. Okay. Now something of note, there's technically 2 return statements in this max method. However, only one of them is executed. Only one will ever be executed. That is, you can only return one value from a method. In this case, we're returning 7. And the moment that you hit a return statement, you actually exit the method. So I'm able to get away with not having an else statement here. We saw actually a couple of iterations, and there are iterations of this this method in the slides. For instance, you could use a variable. Here we're using the variable, but kind of getting rid of the else and saving one of the values in. Here I'm doing an if statement with an else, which is more in line with what I have currently, but technically you can get away without the else because the moment that you hit a return statement, you exit the method, right? You stop operations. We return a 7 here, and boom, we leave. We never even hit this spot right here. Okay, that's methods. A little bit more than what you need to know. What we need to do is get some practice under our belt. Here's another method signature, a completely different method. Write a method, print evens, that prints all of the even numbers from the first specified parameter, that's this one, inclusive, to the second specified parameter, exclusive. Okay, so let's take this method signature. Let's turn it into a method header. It's going to be in our methods class. The name of the method is print evens. It takes in 2 integer parameters. It returns void. We talked about this in our last video. Void means it doesn't return anything, right? This method actually does the printing itself. Okay, one of the things that we're really trying to show is void as a return type. With a void method, we won't have these return statements, right? You won't see the word return show up. In fact, it would be a syntax error, kinda. All right, and this one's going to be static as well. So here I am. Notice that I am defining this in the body of the class, not inside of some other method. We're going to say public static, and the return type here is void. The name of the method is print evens, and print evens takes in 2 integers. Now, it doesn't matter what we call those, right? Whatever we name them here is how they will be referred to inside of the method. I can use X and Y, but I'm actually not going to, just to kind of demonstrate the idea that you can call them something different, right? The X and Y here are actually limited to this scope, which means that down here in a completely different scope, I could reuse X and Y. But I want to show that you could use something else. I don't want you to think that you have to call these things X and Y. All right, so here is our print evens header. It's inside the methods class. The name of the method is print evens. It takes in 2 integers, and it returns void, nothing. Okay, so this thing says it prints the even numbers from the first specified index, or sorry, parameter, this integer, inclusive to the second one, exclusive, so up to that one. All right, so an example of this is 4, 10. All right, so we're going to do all the even ones. We start at 4, we're going to go 4, 6, 8. Notice that 10's not here. That's because the 10 itself is exclusive. More on that later. Okay, to do this, we're going to use a loop. I'm going to plug in my for loop header. You could use a while loop if you would like, but I'm going to create I, and I'm going to start it at bag. In my example, that would be a 4. In fact, why don't we kind of put as a comment an example method call, which would be something like print evens 4, 10. Right? In this example, bag would be 4, end is going to be 10. So we're going to start I at 4. We'll say as long as I is less than end I++. Okay, so notice this is less than end. What that means is that end itself, we actually won't perform an iteration on. That's what we want. That's what the exclusive means. Okay, if I did less than or equal to, then we're talking about inclusive. So what I'm going to do is kind of loop over this number range, right? 4 to 10. We're talking, I got a comment inside of a comment. We're talking 4 to 10. Inclusive, exclusive is going to be our number range. Okay, because we only want the evens, we're going to plug in an if statement. Now, I think some of you may kind of recognize is, well, if you're only doing the evens, why not just do like, plus equals 2? We'll say that I is what it currently is plus 2. Why go plus 1 if you're just going to do the even numbers? Because bag may not necessarily be even, right? We could actually start with like 5. Right? And then you'd be doing like 5, 7. You'd be doing every other, but not necessarily the evens. So I'm going to stick with the I++ and instead nest a if statement to check to see what is the current number. Is it even or odd? How do I know? Well, if I mod 2 is equal to 0, that means it is an even number. That's one I want to print. So I'm going to do a print. Why don't we do a print, not a print line? If you notice, our output is actually all in the same line. I'm going to print the current number because it is even, along with the space. If the number is odd, we don't do anything except an I++ to move on to the next number. And this is effectively it. We're going to loop over this range. With each iteration, we're going to ask, is the current number even? If it is, I print it off. If it's not, if this is false, we just skip it, we increment I, and then check for the next number. Okay, let's call this bad boy. Right? If I model it after this first line here, we'll do an S out on print evens 4, 10. Got an extra semicolon here, and I need one there. This is mad at me. Why is this mad? If I scroll over it, we see cannot resolve method print line void. What is this saying? Well, I'm trying to print what is returned, what is output by the print evens method. The fact of the matter is we got a void return type. Right? Notice there is no return statement. That's correct because we have a void return type. We're saying our method print evens is planning on not returning anything. So whenever I try to print here, I'm printing void. I'm printing nothing. The actual printing is handled by the method itself. Okay. Slightly different ways of doing all this. I'm trying to just show you an example of a void method. Right. And there we go. Let's test some other numbers, right? What if I said like 5 to, we could do 5 to 10. Notice we go over that range. We could actually even do like a -5. And the result is still the same. Cool. One little hiccup with this is that the bag number has to be smaller than the end. Yep, sorry about the cat meowing. But we'll just worry about that later. Here, in this example, I'm showing you the X and Y. I used a bag and end in the code that we just did. Let's look at another method. Write a method GCD that returns the greatest common divisor between two specified integers. GCD, greatest, so we're going to provide two integers and we want to know what is the largest number that will evenly divide both of them. Right? I'm going to translate this signature into a header. I'm in the class, not the body of some other method. We're going to go public, static, it is underlined. The return type on this is int. The name of the method is GCD. And it takes in two integers. Now I'll take the opportunity to prove the point that we can use X and Y. Notice that IntelliJ is not mad at me. This X and Y up here is limited to this scope. This X and Y here is limited to this scope. So they don't see each other. It's a completely different X and Y. Okay, so I want to know what is the largest number that evenly divides both of them. Well, one thing I would want to do is figure out what is the maximum value between these, and then maybe start there. Okay, the logic is, let's figure out what is the maximum, or the minimum, rather. Let's figure out what is the minimum, and then we kind of maybe loop through testing possible divisors until we find one that will evenly divide both of them. And because we're going to start high and kind of work our way down, whatever the first divisor is that we come across, that is the greatest common divisor. So let me show you. First thing I want to do is figure out what is the minimum between X and Y. Right, so I'm going to create integer min. The reason why I want to know what the minimum is and not the maximum is, let's maybe add some values here. Actually, I may have a good example. Okay, 24 and 18. The greatest common divisor is 6. Okay, I want to know what the minimum is. Right? In the case of 24 and 18, the minimum is 18. Thank you. Because that's where I'm going to start my search. There's no way there's going to be a divisor that will evenly divide both of them in the range 24 to 18. All right, so an example call will be something like GCD of 24, 18. I'm going to figure out what is the minimum of these. Super cheeky here. We're going to use the existing math.min as opposed to doing an if statement. You could do an if statement if you wanted to. The minimum of 24 and 18, but not those values specifically, the variables X and Y. I'm going to figure out what is the minimum of X and Y and save it into a variable. That's going to be my starting point. I'm ready to start looping. I'm going to create a for loop, and I'm going to use the IntelliJ for I shortcut syntax. We'll stick with that variable I, but we're going to start high, even though this is called min, is actually pretty high. Instead of us starting at 0 and working up, we're going to start at min and work down. Right? We'll say as long as I is greater than or equal to 0. I'm smiling because that's going to cause us an issue, and I'll talk about that later. And so we're going to start here. In our example, that's 18. And we're going to work our way down, looking for divisors. So with each iteration, I'm going to ask, does the current number, I, evenly divide 18 and 24? That is x and y. If the current number, x mod I is equal to 0. If this is true, this means that I is a divisor of x. But I'm looking for a common divisor, so it needs to be able to divide both of them. If the current number evenly divides x and the current number evenly divides y, it is a divisor of both x and y. And because I started high and I'm working down, this means it's the greatest one because I'm working my way down. The first one that I encounter that evenly divides both of them is the greatest common divisor. I want to stop right here. I'm done. I found it. I want to return I. Okay. Keep in mind what I talked about earlier up here. The moment that we hit a return statement, we're going to exit the method. That means that even though we're looping over and over and over again, the moment that this is true, I'm going to return I and peace out. Okay. This method is mad at me. IntelliJ is indicating this guy is upset. Why? We said that we're going to return an integer. But if I loop over this range, and this is never true, right? I mean, what if our numbers are like 7 and 5? In that case, I never find a common divisor. So what is the GCD of 7 and 5? I guess based on this, we would, in theory, syntactically, though, we're never finding anything. We're going to return a 1 here to make it happy, right? IntelliJ, Java is looking at this and saying, well, if this is never true, right? What if this is false, right? I know you're looking at the screen and you know that that is never false right away. In theory, actually, this could be like a negative value. That's a good way to think about it. Right? If this is like a negative value, maybe we got problems because we're stopping at 0. We should probably make them positive. So let's say that we make them positive. Okay, what if this is always false? I know that is not necessarily the case because at some point I should have a value of 1. But syntactically, Java, IntelliJ, they're looking at this and saying, if this is always false and this is always false, nothing is ever returned. And yet your method says it's returning something, no matter what. That's what this value after the loop is doing. It is handling the, okay, if this is false and this is false, we're at least returning something. Let's try out our GCD. This is the method definition. I need to call it. I'm going to go back up to my main method. We're going to ask, what is the GCD of 24 and 18? I'm smiling because I know we're not getting a value. Well, we are. This is returning something. It's just sitting here. All right, print evens was different because it was a void return type. But this GCD is more in line with our max method because it does return something. It is outputting a value. That value is just sitting here. I didn't do anything with it, but what I could do is print it. So we're going to print off the GCD of 24 and 18. Did I miss something? What happened there? I have a greater than 1 here. That's just an efficiency thing. What am I missing? It's not gray. It's getting called. Oh. It's there. It's the 6 that's right here at the end of this number sequence. Because this was a print and not a print line, we could clean up the print evens, right? You could put a print line after this. You could put a blank print line there, and that would change your output. I'm going to show you something that I would actually recommend, which is instead of putting it here, put it down your print evens. Okay, so that after you get done printing the sequence, a new line is created. Okay, miniature heart attack there. All right, let's look for the GCD of something else. And I'm going to show you kind of the reason that methods are baller. I want to know what is the GCD of, and let's like maybe flip it so that X is my smaller number. I don't know, 40 and 62. You see that we get a 2 out of that. Okay, let's do like one more. GCD of 5 and 7. And that is a 1. Okay, so that makes sense. All right, I flashed something there in the slides, a greater than 1. Let me put that here and then kind of talk about why you would do that. Right, this 5 and 7, 7 and 5 is a case where the greatest common divisor is 1. And we are returning a 1 here. We have to return something after the loop syntactically for the method to kind of work. But realities are that as we're looping, we were hitting that 1 earlier. If we say that I is greater than or equal to 0, eventually I is 1. This triggers and we exit without hitting this. So even though syntactically this has to exist, it actually didn't really have a function because we were exiting the method before it mattered. If we do a greater than 1 here, that kind of makes a little bit more sense. It should never hit 0. It's in terms of efficiency, it's the same thing. One thing that I will kind of test on is what about if we had a negative number here? How can we prevent that? What can we do about that? Looks like it's not an issue. Sweet. Okay. So right here, I mentioned I'm going to do something that kind of indicates why methods are baller. Why are methods baller? Methods accomplish 2 things. One, I hope you see it right here on your screen. I called the GCD method multiple times here. You could do that with any of the methods. What do methods allow you to do? They allow you to kind of encapsulate, kind of wrap up a section of code, tag it with a name. In our example, we're talking GCD. And by naming a section of code, effectively naming a section of code, I can reuse it over and over and over again. Without the method, I would basically, in order to accomplish this, I would need to repeat everything that's here 3 times. Instead, I defined the method 1 time, I gave it a name, and I can now reuse it. So the main reason that methods are baller is that you can reuse them. Okay. Another good reason that methods exist is abstractions, right? I talked about that one in the previous video. The idea that you can wrap up a section of code and give it a name, a abstract name, something that kind of makes sense, right? This one's called max. There's like a section of code. If this was unnamed, it's just a section of code. This is GCD. If it's just a random section of code that's showing up, it's just a random section of code. You're accomplishing a task, but we have wrapped it up and named it. That is kind of the abstraction. In theory, it doesn't matter how you figure out the GCD. In fact, we're actually going to look at a different approach that's more efficient. It doesn't matter the algorithm for determining how to do the GCD. This method finds the GCD. That is the abstraction. We have taken the section of code and named it. Whenever you call GCD, you're going to get the GCD. It doesn't matter how you go about it. That's the idea of an abstraction. So let me show you the other approach I'm talking about. In 300 BC, we came up with a different, more efficient, simple algorithm for computing the GCD of two numbers. Okay, so here is a trace table for GCD 7254, right? When I call GCD 7254, the order of these shouldn't matter, I get 18. That is the greatest common divisor of these two. Now, here is X and Y as they change over the course of the loop. Right, we see 7254. Okay, after one iteration, X is now 18. What happened there? Where's this 18 coming from? Not positive off the top of my head. That looks pretty good. Okay, so we got this 18 by subtracting 54 from 72, and we save that into X. Okay, so this is the state on the next iteration. And you see that our Y got smaller. Okay, so notice X got smaller here, Y got smaller here. On this iteration, X was the larger, X was the smaller, Y was the larger. So here we went down, there. Okay, so the gist of what's happening is, let's figure out what is the maximum between X and Y. We're going to subtract the minimum from the maximum. We're going to override the maximum to be what the difference is. Let's do that again. We're going to figure out what is our maximum, what is our minimum. Subtract the minimum from the maximum. Take that difference, save it into the maximum. We're now at 36. Figure out what is the maximum, what is the minimum. Subtract the minimum from the maximum. Take the result, save it into the maximum. We repeat until one of the values is 0. I'm actually going to shave off this step because we can stop right here. That is, the moment that they are equal is when we can stop. That's super important. Think about this. We're going to have to loop in order to accomplish this, and I'm talking about a stopping point. I'm back in my methods. I'm going to delete that code. You could comment it out if you want. But I was talking about a stopping point, right? We're talking about a condition of a loop. I'm going to use a while loop here. The while loop just is going to make more sense, right? I don't need a counter variable because what we're actually doing is stopping based on X and Y, and X and Y already exist. So no need for a third counter variable. While X does not equal Y. Okay, while the values are not the same, right? Because I told you this is where we're going to stop. The moment that they're the same, that's how we find our GCD. Let's figure out our maximum. Let's figure out our minimum. Whatever the maximum value is, it's saved into max. Whatever the minimum value is, it's saved into min. For the rest of the iteration, I'm going to work with max and min. We're going to subtract the min from the max. And what I want to do is save that into whatever the maximum was. So maybe this wasn't a big bang approach. Maybe I should ask, is X greater than Y? I need to actually know which variable is the larger because I have to override it. We could have used an if statement or something crazy. Anyway, the net result's going to be the same. If X is greater than Y, then we are going to update X. It is going to be X minus Y, right? The larger number minus the smaller number. I just determined that X is the larger number. So X gets updated. Y is going to stay the same. So otherwise, if we hit this, that means that Y is going to be greater than or technically equal to X. If we do that, then Y is going to be equal to Y minus X. So as long as the values aren't equal, we're going to ask, is x the larger value? If so, x gets updated, y is going to stay the same. Otherwise, y must be the larger, so we'll update it. We just keep doing this until they are equal, at which point we just return one of the values. All right, I'm going to return x. I'm going to return y. It doesn't matter. They should be equal at this point. Okay, I'm going to get rid of some of these braces to kind of get rid of some of this vertical space. Let's try that out. I'm going to use the same numbers, right? I'm still calling GCD. We got a 6 and 2. Oh, then a negative number. Say, what? What happened here? Well, if you recall, that was the case, right? Oh, I got a negative number here. What happens if that number is positive? Let's try that. Yeah, there we go. This is a 1. So my method right now does not handle negative numbers very well. When looking for the GCD, we actually don't care about positive, negative. We can just make the values positive, right? So x is going to be a positive version of itself. Y is going to be a positive version of itself. I'm going to run it again. And there we're reaching our 1 value, even though I have a negative number. Okay. Why is this big brain? This is way more efficient than our other version. If you recall, our other algorithm would have started at 54 and went down by 1 value until it hit 18. We would have done whatever the difference between 54 and 18 is, number of iterations. Right, let me bring up my calculator again. Our old algorithm would have performed 36 iterations in order to figure out that 18 is the greatest common divisor. This one does 1, 2, 3, 4 for that exact same number. Way more efficient. Okay. I say all that to say the method is still the same. The abstraction is still the same. This method represents the abstract concept of figuring out what is the GCD between x and y. I used 2 different algorithms in order to do that. The one I have highlighted right now, more efficient by a lot. The other one, less efficient. However, they both accomplish the task. So how the method works is the algorithm. What the method does is the abstraction. Looks like this version did not. Oh, it's very clever. That's not what I would do. That's a little more aligned with what I would do. And keep in mind that neither of these are handling the negative values like we actually did in practice. Let's recap. What Java refers to as a method, other programming languages might call a blank or blank. This is harking back to our other video. Other languages might call a function or a procedure. So these terms, method, function, procedure, are interchangeable. A command that causes a method to execute is known as a blank blank. Right? I told you there's 2 parts to the method. I'm asking what is this called whenever we use the command. What are these? This is what I'm asking. These are known as method calls. Right? That's the section of the code that is telling a different section to execute. The data that is passed to a method via the parentheses of a method call is known as a blank or blank. Arguments or parameters. I touched on this. I want to say we, but I'm definitely going to say I. Most people, I. When we're looking at the method call, we refer to these as arguments. When we look at the method call, we refer to these things as arguments. When we look at the method definition, we refer to them as parameters. The words are interchangeable. Public is an example of a blank blank. Ooh, it's the only one that we're really going to touch on in this class, but it is an access modifier, right? At some point, I will probably ask you, what goes here? What is the first thing in our method definition? The answer that I'm looking for is an access modifier. Public's the only one that we know, but there are more. Private is an obvious one. Here we have a method signature. And I want to know, what is the data type that is returned? The answer we're looking for is int, this little spot right here. If a method does not return a value, the method will specify blank as the return type. Answer we're looking for here is void. We actually have two examples in our code. The main method is in fact a method, and the return type is void. Notice that it does not have a return statement. Our print evens is also void, no return statement. However, with max and GCD, we said we're going to return an integer with both those methods, and they both have return statements. GCD only one. Max technically two return statements, but keep in mind that no matter however many return statements you have, only one would actually be executed, because the moment that you return, you exit the method. Right? We saw that with our other GCD algorithm. True or false, a method can return an object. Ooh, that's true. If it's a data type, it can be returned. Examples of objects, we're going to see string as a big one for this whole unit, but we know scanner, random, those are technically objects. The parentheses that indicate what parameters a method will accept can be omitted if the method does not accept parameters. What am I saying? No examples here, but just imagine that we wrote a method that doesn't take in any input. That's possible. It's possible to write a method that doesn't need any input in order to produce an output. But what the question is asking, can we get rid of these parentheses? And you will see that right away, IntelliJ says no. So this is false. You cannot omit those. The braces indicate the body of a method can be omitted as long as there's only one statement. I don't think any of the methods we're going to write in this class will have one statement, but it's asking, what if we got this super sweet max method that just returns y no matter what? Can we omit these braces? Right? It's kind of like our for loop. I omitted braces down here. Our if statement, I omitted braces. I did some brace omission down here. Can I do it for a method? The answer is no. Methods are not control statements. They're not the same category as for loops and if statements. We're actually going to pause there. We'll pick up in our next video doing some coding bat finally. I'll see you then.